Hello, everyone. I'll just wait a few minutes so everyone can be seated. Thank you. So, thank you, Cécile, for introducing me. I'm Lola OVARLEZ, and I'm delighted here today to have this great panel to talk about a really important subject, which is the transportation of electric vehicles and lithium batteries, especially at sea, but we are talking about that subject in a more general term. I'll introduce my guests in a few seconds, and then later on they will have also some opportunities to tell us a bit more about what they do for their companies and everything. You can see the names here, but again, I will introduce them soon. So, well, why are we talking about these subjects today when I think most of you here remember some big incidents that happened, especially last year, but there are always some news in the media about new incidents, for example, the Fremantle Highway. When we look at this picture, I think you've seen a lot of pictures already, we get kind of scared about potential dangers of transporting electric vehicles and lithium batteries. Well, you'll see we'll talk about risk here today from very different perspectives, but we will also look at a more brighter side. Solutions are already in place, but also solutions that will be brought in maybe the few next years. So I'm glad here today to have Damien. Damien, you are a consultant expert Nouvelle Énergie et Mobilité at CNPP.
Yes.
Next to you, there's Martti. Martti, you're a loss prevention manager at the Swedish club. Sorry, let me just put your names back. Oops. Okay. Next to you, coming from London, we have NUGENT, Marine Superintendent at NYK. Then we have Anna KARLSSON. She's a fire engineer at the Research Institute of Sweden. And finally, coming from Germany, we have Andreas MAIER, who's a specialist risk engineer at BMW. So, I think I will start with you, Martti, perhaps. Can you tell us, because you represent, and you can introduce yourself and tell us more about the Swedish club, but you represent the marine insurer perspective on this panel. So can you tell us what this industry fear when it comes to transporting, EVs and also lithium batteries? What are the concerns?
I think the main fear is the fear, and there's uncertainty. Do we understand the risk correctly? We have kind of, in very broad terms, two sides of the coin, if you like. We have the science-based approach, that we have lots of scientific projects and data and information that we can use and base our risk assessment, loss prevention on that. And then on the other side, we have the fear-based, that I think this is really bad, the world will be in fire. So I think this is the main concern, that speaking very broadly for our industry, that we should perhaps align a bit more, and I will come back to you where we should align us.
Do you think, because when they see, for example, the pictures of the Fremantle Highway, do you think they think every time there's an EVs or lithium batteries being transported, they will end up, making a big fire in the ships? Or, what are they actually fearing? Is it exaggerated, or?
I think in this particular case, there are roughly 800 PCTC vessels around the globe. And how often do we see in the news that they are actually on fire? And I would go as far as claim that so far there's no confirmed factory new EV that has ever burned. There are speculations about it. But of course, the insurance fear is that if the worst happens, there's a total loss and loss of cost, and in the very worst case, that the human lives are lost. Mm-hmm. So
Thank you. Alan, maybe I can turn to you, because, not to contradict Martti's point of view, but I think you see maybe more closely as part of the NYK, which is a carrier company, what actual dangers can be linked to transporting those typical goods?
Yes. What we think from our side, when it comes to fighting any vehicle fires, the initial actions are going to be the same. You deal with the fire with probably fixed firefighting. But the issue there is with EVs, so far as we know from our understanding, there is a possibility of reignition. And that needs a different kind of tool. You have to consider your different approaches then. And this is where our main concern is. The other big thing that we find is actually the labelling on the vehicles. When, in the reality, when you're dealing with these units going onto the ships, you see 1,000 cars that look almost the same. They've got a full body cover or something, and you've got a label that might say EV, or it might not.
Oh, so we just don't know.
Sometimes we don't know.
Okay.
So we have to have the guys going on board and looking to see how they can identify it, because we have to block stow on board so that we know where these units are, so the crew can adapt their strategy if anything does happen. And that's the main concern here from our side. And also when things go wrong, we then have the risk of, well, we're told that if there's a fire, you have to react within 14 minutes. That's a very short time to do anything. You imagine 2 a.m. in the middle of the ocean, someone awake, and you have to be fully compos mentis in 14 minutes, and to react within that time is a big challenge.
Thank you. I think you put in some slides about...
Yeah. That's just about background of NYK.
This is go ahead, sorry.
So these are recent cases, and you know, when you look at these, yes, there's vehicles involved, but there's only 2 cases here that there were EVs on board. And you know, this is where a lot of this was down to the time. But this is conventional units. And if you don't react in time, this is the problem. And adding EVs on top of it, there may be some risk, but we need to know how to approach this. And that's the point from our side. And we need to know what we're loading, basically.
Yeah, basically. Yeah. We will probably touch upon that during the solutions panel on how we can improve the labeling, maybe. Just proposing here. And so it kind of goes at the end to what Martti said about, you know, there are fears, you are living them, but we need to look at it from the science fact. And you said there's almost all of those incidents did not occur because of EVs, or we have no idea, but probably not.
No.
Correct?
Yeah, if there's only 2 that there were EVs on board, and both cases there's no direct link. There's no direct link at this time. Okay. Yeah, so there's not much we can say until until something happens, and I think that's the main point that we're seeing. Yeah. And obviously we don't want that situation to happen, but we need to watch and find out
and be prepared.
And be prepared.
Yeah. Perhaps coming back to the science-based approach, we need to look at science in this. And we are lucky to have Damien and Anna, who are experts in this from the engineering side of it. Damien, maybe you can, tell us a bit more what you see from your perspective at CNPP on, the risks that are linked with transporting EVs, especially with the batteries, lithium, how they can catch fire, how likely is it, how difficult it is perhaps to extinguish them,
Ok. Je vais continuer en français, comme ça mes compatriotes.
Right, so I switch to French so that my fellow French speakers can take a rest. So a lithium battery, well, we all think that this is something that is inert because we find them in our phones and in our other household appliances, but it's not the case. As you can see on this slide, you have an anode and a cathode with a flammable liquid. So here we're talking about dithic carbonate and other types of carbonates. And we're talking about 20-30 degrees. So you will have a small tank or a bigger tank if you have a bigger battery that will contain a fuel, and at the same time the energy that is necessary for this fuel to be flammable. And as Martti and Alain were explaining, if we are only looking at the facts, statistically, it is very unlikely for a battery to catch fire. So we're talking about a probability of 10 minus 7 for a good quality battery with a battery management system, so a sort of brain that can manage this battery well.
If you look at statistics on vehicles, it's very interesting. On screen here, you've got two different stats, one from the NTSB, so it's really a US statistic. If you look at families of vehicles, if you take 100,000 electric vehicles over a year in the US, out of 100,000 EVs, 25 burns. Out of 100,000 ICE cars, there were 1,530 fires. So the ratio is very clearly tilted in favor of EVs. But be careful, take these figures with a grain of salt. You understand 100,000 ICE cars, the average age of cars in the US is about 11 years, 11, 12 years. For an EV, of course, the cars are much younger. These figures need to be compared with our Norwegian neighbors with which we've worked at the CNPP. Right now, they've got about 500,000 EVs driving in Norway and 17 fires in 2022. So these are very rare events. There's no distinction between arson and non-arson fires. It's all fires combined for EVs. In terms of likelihood of occurrence, it's very much in favor of EVs. But if you need to intervene on a battery fire, for a car or battery storage, it's very difficult to put out. You need to cool them down a lot. You need to drown the battery in water. An order of magnitude, the water requirement for an intervention on a car with the traditional access, fully developed fire, no constraint of access, no constraints in terms of water to attack it. With an ICE car, 500 liters to 1 cubic meter. It takes over 10,000 liters for an EV. If you look at the feedback from firefighters, it's even 100 cubic meters, 100,000 liters of water, even more. So the amounts of water are very high, and you can imagine that on a boat it can be very problematic. Thank you so much. Anna?
All of that. Yeah, great. Perhaps you'd like to, maybe complement what Damien said, or maybe, as a fire engineer and you work in Sweden, you maybe have another perspective on this, and I think you work closely about this. So what can you tell us about those risks that, maybe Damien didn't touch upon, or that you would like to complement, or, you feel free.
Yes, thank you. Yeah, well, in RISE in Sweden, we have kind of the same numbers, I would say. I don't have them in my mind, but for a fire starting in the battery in an EV, that is very rare. But of course, the statistics will change during the years, and when more people maybe have EVs, and maybe the numbers will change. So we need to kind of track the statistics also. So yeah, that is the first. Yeah, I agree. So the risks are not higher, but the aging is also a little bit hard to predict. So we are now in the new, still kind of a new era of batteries, and the development is increasing rapidly. We need to, as a researcher also, and the industry, we need to understand and keep on learning and how they behave. I mean, we also learned some years ago, or a lot of years ago, how our conventional vehicle and the hazards with the diesel and petrol, and that is other kinds of hazards that, I mean, a vehicle fire on board, that is devastating, even if it's an EV or a conventional fire. You don't want a fire to grow large. So that are some of the concerns, and I think we touched upon it as well, like the consequences to be able to extinguish or to handle it. We know that batteries are extremely hard to cool down, and we will have a lot of extinguishing water. This is also coming with some environmental hazards, like more maybe toxicity in the water. So that is another generation of questions that is adding. I would add maybe the used cars and the aging of the fleet. I mean, as of today, we also see we will be able to transport used batteries and used cars, and that is problematic as it is today. So that is another concern.
So the main thing that we can remember is that there's still so much we need to learn actually about to be able to fully comprehend all the risks that are associated with those batteries. Is that correct?
Yeah, exactly. But today, the risk is we should not be feared. We should, as of today, the risk is very low to start firing a battery.
Yeah, do you want to?
Because we know there is a cycling aging and a calendar aging on lithium batteries, so we know that all the statistics are wrong, already wrong, and the number will increase for lithium batteries. We know that, but now?
Yeah, exactly. So we the researchers, and together, I think, as a round table and in projects and together in the industry, we need to work on this together to learn and to increase the knowledge and spread it. I mean, a safer work environment and for everyone to understand.
That's why it's really good that you're all here surrounded and being able to say, don't be afraid. It's going to be okay. You just need to learn more. Andreas, maybe you can tell us from the manufacturing side, because you work for BMW and you have a more concrete, actually, I mean, not concrete, but you work for a manufacturer that builds those cars and the lithium batteries, and you know the risk, and perhaps you also have risk not even before they reach the ship, for example. Can you tell us a bit more about, what is it to, manufacture those goods?
Of course, I'm happy. We as a manufacturer not only have the risks or the transport side of finished serious production cars that go onto a ship or a train or a truck or whatever to be shipped from our manufacturing plants to the customer or dealer or wherever they have to go, but we also have everything that comes before. So we do all the research and development. We have to deal with prototype cars. We have to send them to the Polar Circle for winter testing. We send them to Death Valley for summer testing, for heat testing. So we have to do the transport as well with prototype cars, prototype batteries, and also we have the whole logistics side from the supply of the cells till the finished battery, and then we have to move that from the battery assembly to the final vehicle assembly, which is not always in the same place. It can be a totally different plant in a totally different country, for instance. So we have to take this also into consideration, and what we have done, or what part of my job as a risk engineer at BMW Corporate Insurance is making sure that for each and every step we have the proper risk mitigation, and we have the proper like sprinkler systems or fire detection systems in place where we need it. And once we come to the final stage of transporting finished serial production cars, it's actually the easy part, because these have been tested hundreds and thousands of times during the whole cycle. These have been homologated for the different markets, and they comply with all regulations for the various markets. And from our point of view, we can consider them safe to transport, and of course safe for the customer to use and use on the road and charge at home in his garage. So and the interesting part is actually what are we doing for quality assurance during the whole production cycle of the beginning from the battery cell to the finished battery, and then it goes on when it goes into the car, when the whole car is assembled. There are also a lot of tests going on. I will refer to that later a little bit, and that's going to be interesting. But there's a lot going on before the transport side, actually.
I'm not asking you to speak badly of your competitors, but you speak a lot about all those testings, and as you said, we will see in the solutions what you do on the manufacturing side. Do you know how other of your competitors, are they as thorough when it comes to testing and making sure throughout the manufacturing line if everything is good with their batteries? You don't. Please don't speak names.
The thing is, I can't really speak names, and I would think that they have basically a similar approach to ensure that everything is okay, because they also have to meet the criteria that are required for the market. So somehow they have to prove that their cars meet all those criteria and regulations, but I can't say a word about the process and how they go there, because I just don't know.
So there are criteria that apply to everyone. That's what you said?
Yes, of course.
Okay.
There are regulations for EVs in many different countries, many different regulations, and they all have to be met if you want to sell a car in this particular market.
Are they sufficient to your opinion?
At the moment, I would say yes, but you never know what the future brings. And the problem about it is there's a very general approach on what a car must be able to handle, like impacts or temperatures or things like that. But the technical specs of the batteries may be totally different. So one manufacturer might have a totally different cell chemistry than another, and a totally different build-up of the whole battery pack than another one. So this is on the manufacturer side to ensure that everything complies and that they have the best product possible.
Damien, I see your...
Pour compléter ce qu'a dit mon...
To add to what my colleague said, keep in mind that, as Andreas said, there are a lot of different batteries. We're talking about lithium-ion batteries. We get the impression that a battery is just any battery, but it's not that, in fact. For EVs, there are three main families of batteries that some are more sensitive to others than other stimuli. Typically, NFP, lithium iron phosphate, withstand temperature increases very well. So if there's a thermal runaway that's rather slow and well managed, well, if it's violent, they will cope difficultly, just like the others, but LFP is better than others. And as Andreas said, for car makers on the global level, Renault had a very operational approach by having a fireman access in their batteries that was developed with Paris firefighters, so that with a fireman hose you can drown the whole battery casing at one go, so you can cool it down. As Anna said earlier, you need to cool down the battery as best you can. And Renault's integrated that in their vehicles, but it's not at all a standard globally.
Anyone would like to add anything? I see that you kind of all agree. Martti, you seem suspicious, or maybe you have something to say.
No, far from suspicious. What I think, coming from insurance point of view, that and having this round table, that it's very important that we work together. That we have the manufacturers, we have the research institutes, and we have the transporters, and one thing I think went through the slides, the IUMI position paper is one very good example of that. That we actually, all who sit here, were part, except you, we're part of this paper. That how should we understand this risk? Are the risks greater? If so, how do we do? If not, how do we do? And what are the assumptions based on? And it's actually very much a science-based paper and science-based opinion. And we were together with Anna and Alan in the Lashfire project. It's so far the largest EU project, 13.5 million euros. And it was the first time that the marine insurance was part of it. And I'm very happy I had the opportunity to represent both IUMI and C4, so that we, as an industry, insurance industry, that we take active part in these discussions, that we understand the technology to a reasonable level, so that we can actually do meaningful loss prevention. If we don't understand the risk, what are the risks, how they're interconnected, then we cannot do meaningful loss prevention. So that's my take. Not suspicious.
Not suspicious,
making
no,
my point.
not at all.
Yes.
That's great. I mean, this is a nice segue into the second part, if if we may say so, about, the solutions, or, perhaps the improvement, what is being done actually. And Andreas, you talked about this, so I'll give you the mic now. Maybe you can continue, and you have some slides as well. Yes. And how can we do better? How can we, improve from all your different sides?
Okay, so these are my slides now. As I said before, I'm going a little bit into detail of how our quality assurance process looks like, and how the complete process of getting the battery cells delivered through the stages to build the final battery and then to implement it in a car. There's, as I said before, hundreds and thousands of tests going on just to ensure that everything in this battery is according to spec and how it should be, and there is nothing wrong with it. We can go over this one. So here you can basically see this is just how the process looked like from the cell supplier here to the vehicle distribution. And it starts with the cell supplier. We do lots of tests. I won't read them to you because you can read it yourself, and you don't need me to read it out. But what I want to point out is that we have in various stages, beginning from the cell supplier who manufactures the cells to our exact specifications, just as we tell him that we need the cells to be. And there's a so-called end-of-line testing at the supplier. And he is testing every single cell to the specs, and then they give us like a spec sheet, and we take the spec sheet and then we double check it once we receive the cells in our factories. We just double check if everything is okay and if the electrical criteria and everything is measured properly. And once this is approved, then we put it into production and it goes on. If this is not approved, or for the cells are being too old, for instance, or have the drop in the state of charge from the manufacturer to us is too high, then we sort it out, we send it back to the manufacturer to just redo it, and we won't even take it into our production lines. From there, we do the cell coating, which is the next one. Yes, that's a good one. So here you can see, like, I call it a naked battery without any coating on it. There's no electrical insulation around. This is how our cells look at the moment for the current generation. As I said, lots of tests are going on. We measure the inner resistance, the voltage, and so on, state of charge. And then, can you go to the next slide, please? We cover basically the whole cell with a UV lacquer just to insulate it against each other electrically. And the insulation properties, they're also measured very carefully, and yeah, we really have to make sure that everything is according to spec and that everything is okay. And only if these criteria are met, it goes to the next step in production, which looks like this. That's a little bit complicated. This is an exploded view of one of our modules. That's not a finished battery yet. This is like a stage in between where we create energy modules out of the single battery cells you've just seen. These are the blue ones you can see here, and we have many other different things going on. We have heat shields, we have additional electrical insulation, we have the ability to heat and cool the battery according to the surroundings. Everything has to be checked and measured, so if everything is coolant tight, so we do a pressure check on the heating cooling system. We do tons of electrical checks on these as well. Geometrical checks, we check for technical cleanliness, so we have cameras looking at if there's any kind of debris going into it. If there is, we sort it out, and we either redo it or we throw it away, and only the good ones go into the next step, into the next process, which looks like this. This is one of our batteries, and the black stripes, so the black packages you can see are the finished energy modules that we've just seen before, and depending on the size of the battery, more or less go in there. Everything is connected electrically, and also the cooling system is connected. It's double checked again, and then finally the battery management system is put on top, which is like the brain of the battery that can communicate with the car and then can measure the electrical and thermal health status of the battery itself, because the batteries have thermal sensors, they have electrical sensors, they can more or less detect if they're in a good health or not. And then we go on to the car manufacturing, to the vehicle manufacturing. Then you can see on the next slide where the battery goes inside the car. This is a BMW i4. and you see the battery is going underneath because of it's an ideal place for a battery for low center of gravity. It's protected against impacts and things like that. And in the vehicle plant, the connection between the battery and the head unit in the car, which is also the brain of the whole car, not only the battery, is double checked. And if there's communication going on back and forth, because the car can even tell the driver if there's something wrong and he should go out and leave the car immediately because the thermal runaway is due for whatever reason. But this is, as we said before, very unlikely. And yeah, so on this stage, the car can communicate with its surroundings. It would also be possible when it's parked somewhere to warn its surroundings. It can blink with its blinkers, it can blow the horn so that it makes the surroundings aware that there's something going on with this car. But as I said, it's a feature that we don't need more or less, or not very often at least. Okay, next one please. Oh, this is already it. I tell you something about our about the process that's coming from here. Yep. This is the transport, and basically we do two things to ensure a smooth and even safer transport than we would already have with our finished product. One thing is we lower the state of charge, the SOC in the battery, to the minimum possible level. This has two benefits. One is that the likelihood of a propagation, that's a chain reaction inside of a battery, is lower with a low state of charge. So the lower the state of charge is, the lower is the likelihood of a chain reaction happening. And with a very low state of charge, we might not even see a chain reaction. It might not even take place if it's going, if it starts inside the battery. And the second thing is we put our cars in something we call a transport mode that disables all the comfort features in the car. So you have no heated seating, you have no air conditioning, you have only access to the electrical things that you really need, like the motors. You can drive it, of course, you can unload it and load it on a ship. This has to work, of course, but it's very limited also to save and to conserve the energy. And yeah, this is not exactly because we would need it, because there are some regulations from the transport industry that tell us to be under a specific state of charge, but it also comes from our own safety concept that we have in our whole plant. So we have a certain state of charge fixed with our insurer that we currently have, and also with the sprinkler people, with the fire detection people. We all agreed on one specific state of charge that is considered safe enough for them, and we get the cells delivered at this specific state of charge, and from there on it only goes down, because we try to avoid recharging in the whole process, because it's a logistical nightmare and it's also very cost intensive. So for this reason we have a very low state of charge in the final move or in the final transport.
Thank you. I've seen some heads nodding about the state of charge. Maybe anyone? You said, Andreas, that it was not like a requirement from everyone. You do that, right?
Yes, we do it, but it's not a requirement, at least not one that we know that comes from the transport industry. The only hard number I know now is 30% state of charge, and that comes from IATA for air transport, but that's it for now.
I see a reaction from Alan and also from Damien.
Well, from our side, it's NUGENT have a limit of up to 50%, but
that you require from
for state of charge.
Oh, sorry.
Yeah, but but throughout the industry, whoever you ask from different carriers, you will get different answers. This is a big problem that we have from our side, but this is being worked on and discussed to try and align. I think Martti probably.
Yeah, Damien first, and then Martti.
Oh, go ahead.
Or one or the other.
Yeah, let's just continue what Alan said, that this highlights again that we need to work together as an industry. As an insurers, are we happy with 50%, or should it be 60% or 40%? And quite often, depending on the working group, that if the manufacturers are not there, that well, we would do all these things, but the manufacturers, they do something else. And that's why I think it's so important that we sit together, and then we can, Andreas, can you build a car that can run 1,000 miles with the 10% state of charge?
Not yet.
Maybe not today, but I mean, and then we understand the risks. And same that when you need to transport it, that you know that it's safe enough to take on your vessels.
Yeah. Damien?
To complete, in France, French fire laboratory, which called Ineris, made a lot of tests, and they said a few months ago it was under 30%. You have a standard risk. It's not a specific risk, but in fact you don't have to have a state of charge too low, because if not, you can create plate in the electrolyte. And you could have other problems during the charge, you know.
Yes.
So if you must be very, I think between 15 and 30% perhaps, but not lower, because you have other risks which could appear.
That's true, actually. That's also a problem that we face, because we have to distinguish, or at least we do distinguish, between a technical state of charge, which is the actual amount of energy inside the battery, and the one that is displayed in the car. So when the displayed state of charge is at 0% and the customer cannot drive a single centimeter anymore, there's still energy left in the battery. Also for these technical reasons, because if you really discharge it too deep, the battery will also be destroyed, and it can cause problems if you try to recharge it then.
Martti? Oh, Anna? Anna.
Yeah, but I think as also Alan said, like in the regulations, we are not really there yet. Or we look at aviation sometime on the transportation and the state of charge. So maybe if it's needed, we should align ourselves. But in my understanding, the consequences is one aspect of the state of charge. So if the higher percentage, also the consequence can be a little bit worse than if you have a lower consequences. So that is, you don't want it to have it too high, but yeah, not too low.
Not too low.
Either, exactly. But I mean, we also have the cars coming on board, not only the vehicle carriers, we have them in RORO passenger ships as well. So yeah, there are risks in other vessels where you want to have 100% perhaps, you know, because you're driving through Europe or something.
Martti?
Yeah, it's just wanted to make the point that there are batteries and there are batteries. And the aviation hard number is from basically your Makita drill battery accident. There's one single accident, and that's at, well, 30%, no more. And these are batteries without the battery management system, whereas what Andreas is building is a totally different thing. So there are batteries and batteries. Yes. So we should have a clear distinction between the toys and the professional stuff.
Alan, let me get back to you, because right now we are talking about, you, Andreas, talked about what you're doing from the manufacturing side. You talked, all of you, about what we should do with the state of charge, for example, that we should come together and, kind of not decide, but maybe discuss what's the best. But you, Alan, what do you do right now with your carriers to make sure either to prevent any incidents or basically to do the best to stop it?
Well, what we do currently, our approach is 4 points. So we look at prevention first, where we ask for information from the OEMs, tell us what your car is, what we can expect to load, and also maybe some emergency contact information, so that we can contact someone at the manufacturer side to give us some assistance if anything goes wrong. Then we have to look at early detection. When we're talking about the 14 minutes, we have to think, how can we reduce the reaction time? So from our side, we're looking at AI-powered CCTV installed on the decks. There's other solutions being looked at throughout the industry for different detection systems. But then we also have to look at the firefighting side. Now, we've done tests with foam. We're wanting to do some more testing on the CO2 side. We're looking at better fire divisions, because these ships, these are like 12 decks most of the time. Sometimes it can be 2 fire zones for 12 decks. So even splitting that down to 3 or 4, it makes it a little bit easier to know where you're targeting to fight the fire, giving better tools on board, better training to the crew, and giving them the possibility that they can even fight manually if they have to. So there's been a big concentration on fixed firefighting, but we also need to think about, yes, that's one one point, but we also need other tools in our arsenal, which has been looked at, but we want to see where we can go with that and what works. And then it comes back to, if everything goes wrong, evacuation routes. Now we saw in a recent incident where the crew couldn't get to the lifeboats because of what had happened to the top deck of the ship. And so we are having to look at how can we keep our crews safe? How can we get them off the ship if all else fails? That's our biggest concern. So it really goes down to our main points are, firstly, crew safety, safety of the vessel, and then it's the safety of the cargo. We want to make the cargo safe for everyone and get it to Andreas's customers. But we need to make sure that we're doing it with the safety of the people on board in mind.
Thank you. Damien, maybe.
Damien, est-ce que vous souhaitez nous dire un peu ce sur quoi vous avez travaillé au sein du CNPP? Alors, vous avez dit que vous avez besoin de solutions, mais il faut les tester. Il faut tester l'efficacité de ces solutions.
Nous, chez CNPP, on fait brûler des batteries de véhicules.
So, we've been experiencing fires on batteries since 2002. And so we need to change our approach. Because I think that we have been focusing on standard starts of fires. So when we're talking about detection, so we're going to have a detection system that is adapted to a standard fire. But this is not well suited to batteries, because batteries, depending on their state of charge, as we explained, can be more or less sensitive. It also depends on the chemistry that is involved, the chemicals that are involved, lithium, iron, phosphate. It can be more stable. NFP, and when we increase the temperature, it doesn't change a lot. But then you have other cylinder-shaped cells that you can find on Tesla cars, for instance, that are going to be more sensitive. So I'm not saying that other brands are better than Tesla, but maybe they are, just in terms of safety. So we need to change our approach. To this day, all detection systems have been designed with this in mind. But with a different stimulus, you might get a different response. So sometimes you can have a very violent fires that can go to an explosion with a gas release on a vehicle. It's rare, but it happens. And sometimes there can be no fire at all. There can be a strong gas release and a temperature increase, but it will not catch fire. And so we're really at the top and the bottom of the spectrum. So at Ineris, Effectis, CNPP, or RENDEZ in Germany, we need to run tests in order to be able to produce standard fires in order to test the solutions you need, both in terms of firefighting and detection. And that's extremely important because not all batteries will lead to the same type of fires. So we need to be able to say, well, this solution will work in 70, 80, 90% of cases, and that would be great. But we should not forget that you will always run a risk with batteries, because to this day, there's no solution that is 100% efficient.
Yeah, well, as Damien said, we also investigated fire safety in batteries for almost 20 years now, and actually we have invested in a battery safety lab, so we can actually do a lot more testing in a safe way, both for us and the technology, so we will hopefully be able to follow the development. And we have seen that, or as we talked about, like the water extinguishing systems on board, they are generally working on vehicle fires and electrical vehicle fires. Maybe the foam and the carbon dioxide is not really investigated yet, but we have started at least a carbon dioxide extinguishing project, so we will investigate the effect of these agents on the battery cell level and up to a vehicle level. So also in those tests or projects, we always have like a reference group, or we need the industry to be part of those experiments and the development in the research projects. So that I wanted to add a little bit here. But working with authorities are also like important to have the regulation and their understanding on how we can proceed. So yeah, maybe that was a little bit.
Martti?
I'm just curious and waiting.
Okay.
Yeah, I agree. And adding on that, perhaps with the risk of repeating myself, that we work at the IMO, we work in the IUMI, C4, we work together with the research, the transporters, the manufacturers, that somehow I still feel a bit lonely sometimes, that I think that as in marine insurance and insurance industry, that we should cooperate where we don't compete, and safety isn't one of them. So I do want to see more of our insurer representatives to actively take part in these important forums, that we understand what you are researching, what you are building, what you're transporting, and what we are actually, at the end of the day, carrying the risk for.
Anna?
Yeah, actually I was coming back to the kind of the crew and the handling. So I think also in the, or now, but also in the future, a solution, as we talked about, is the organizational factors. Like, so the crew should be able to work safely, that is not in conflict with fire safety. I mean, I can see, I'm not in the field, but I can see thousands of vehicles being loaded on board, and you know, there's also maybe hundreds of stewards being there, and during this time, for example, we have you can shut off the detection systems, and then I mean some of the safety routines might be changed. So this is also where we need to do a lot of research and together work in finding a good way forward for the organizational and the manual work.
Martti, and then we will move on to our final remarks.
Yeah, just to introduce the team for the next year's conference, that we are very much concentrated on what happens when vehicles burn on board when at sea. That we can, I would say that if we act within your 14 minutes, I think we are fairly well equipped to deal with that scenario. But there's a totally different ballgame when we are alongside in the port, because then all the systems are put out. And this is something that should be addressed globally. In very few ports there are any fire brigades that can even orientate on board. There's no capacity, no experience, nothing to deal with the vessel fires alongside. So that's, in my book, the very first case. And well, maybe we come back to the next year, but just wanted to introduce it.
Okay. Since you're talking,
just on that point, I think that kind of echoes what we as carriers are looking at. We very much looking when a vessel's alongside, how can you buy more time? Because if it's like CO2, and even with foam, you have to seal up the vessel. So you have to close the area that the fire is, and then you can fill it. You can start filling it with foam before you close, little, but not completely, and it won't be fully effective until it is closed. But you can start. So this is what we're thinking. We need time. We need to find ways to buy time to deal with these situations when alongside, and that's the big concern that we have, I think, as well.
Let's wrap up this panel with some optimistic remarks. So anything that you'd like to say to the insurance and everyone here in the audience, what should they know? What should we work on for the next future, for the next years? Anything you would like to conclude? So, you know, that's the last thing they will remember when they leave the room. Andreas.
Okay, maybe I just add to the point that you just mentioned, buying time. What we found is that the sprinkler system, just a regular sprinkler system that you can have in more or less any building, already buys you enough time for the fire brigade to have a chance to address the fire at the point where you have to go, and then to cool it down manually at the exact point where you have to cool it down. So this is already working pretty good. And I don't know if it's possible to implement it on ships as well in this high water dose that we would need, but that might be something we could think of. And for my last words, I'd like to say that we do a lot of research and development on our side. So, for instance, we have our own fire lab ready in half a year or in a year's time to be able to conduct the tests for ourselves. And yeah, whenever it goes to the transport that you guys have to deal with or you guys address, you can be assured that it is a finished serial production car that has undergone many tests and should be considered safe to transport and also safe for the user. And of course, in the future, we do a lot of research and development, and it doesn't stop with the Gen 5 batteries that you just seen today. We will release our Gen 6 battery cars in this year already, and we are already working on Gen 7, so there's a lot of going on behind the scenes, and you can be assured that we have a really high focus on safety.
Damien, final remarks?
Tout à fait. Je pense qu'on est face à un risque de...
Absolutely. I think that we are experiencing a transition. I think that EVs are becoming more and more common, and we need to find the right solutions. Alan was talking about foam, and what we need is really to cool down batteries. Some ships are equipped with foam systems, but it's not necessarily the best solution to put out a battery fire. And we need to be very careful because a few Scale 1 tests have been run with over 3 vehicles in the world. And there's no test that is actually representative. So we cannot guarantee that these systems are going to work every single time. So we need to be very cautious. It's true that these standard systems will help us buy time. And it's not going to put out the fire, but it will allow enough time for the fire brigade to intervene. But we need to make sure that the systems that we install are efficient, or at least in most cases, to make sure that we can reduce risks.
Right. Alan, final remarks.
Well, I think it comes down to we need cooperation and communication amongst everyone. And it's been echoed here, and you know we're getting it with the round table with these actors, but sometimes there's other parties that we don't get as good cooperation, and I think this is what we need, industry standard moving forward as a real way to drive that safety.
Anna, Martti, do you agree?
Yes, cooperation and communication, and I would just say here to the audience is that what mainly burns in a vehicle is actually the plastics. It's not the battery itself, so, and that is the same. And we need to learn the hazards coming with this new hazard of batteries. But we have learned, I mean, previously in the history also about fires, so it will go on.
If I haven't been clear enough, I would make the point that as an insurance industry, we should align ourselves and we should adopt science-based risk understanding. Then we are never ashamed how we deal with the risk, how we mitigate, how we do a meaningful loss prevention. Thank you.
Thank you everyone for listening to us. I hope you learned a lot, and I think this panel is a really great example of what you all said about cooperation and exchange and communication. And I hope you will remember that. And I hope you had a great time, and it's soon going to be time for lunch.
Et on peut les